This video is not to show you how to calculate set and drift for the United States Coast Guard Captain's Test. If you don't already know how to calculate set and drift, you're probably going to want to find another video. But if you do understand how to calculate set and drift, but maybe like me, you're frustrated with the fact that the answers you get really never match the answers on your practice test that you have, and they might be close, and some of them are way off. It's just not very consistent. After studying it, I think the thing that I want to show you today is why you're never going to get the right answer to any of these practice problems, why you should stop trying to get the right answer to the practice problems, how to get the correct answer on the test every single time, and do it in about half the time you would need to actually calculate the set and drift for the problem. So let me show you how we can do that. I find the difficulty in solving set and drift problems in a way that matches the test answers to be based on two general things. We don't know the assumptions used by the person who authored the test questions, and it's extremely difficult to plot and measure very short and very specific vectors on a chart created at the scale of 1 to 80,000. We're never going to get the answers to these questions exactly correct. To make my case why I think this, let me start with a problem that I got from my captain's training class. I'll put it on the screen if you want to try to calculate it for yourself, but I'm not going to take you through my calculations. I'm just going to hit my findings. I come somewhat close to solving this problem. It was close enough that I could guess the correct answer without using the hack I'm explaining in this video. The first key thing to note in this particular problem is the exact timeline of the problem evenly divides into 1 hour. 1 hour and 24 minutes is exactly 1.4 hours. It's not 1.433 hours or 1.38 hours rounded up to 1.4. We can assume that the author of this test question must have used 1.4 exactly when using any rate times time equals distance equations. 1.4 times the speed of 6.4 knots yields exactly 8.96 nautical miles. That's pretty specific, but this is where the assumptions start. Did the person who authored this test question use a distance of 8.96 nautical miles, or did they round up to an even 9 nautical miles? Well, that's not a very big difference. I have learned that even 4/100ths of a mile can introduce a couple of degrees of error into an answer, and I'm going to show that later. Next, the per standard compass heading in the problem was 028 degrees PSC, which is very close to lining up with exactly plus 3 degrees or 3 degrees east of compass deviation listed for the heading of 030 degrees magnetic. Again, it's probably very safe to assume the author of this question used the 3 east or plus 3 deviation when they determined the boat's dead reckoning fix at the end of the question. Even with being able to rely quite strongly on the small differences and assumptions that you need to make to solve the problem, the best I was able to do was get an answer of 238.5 degrees true at 0.857 nautical miles. I want to pause and note I was trying to be so specific and exact that I did my best to get the answer down to the half degree, which I think is dumb. Plotting half-degree differences on a chart with a scale of 1 to 80,000 is beyond human ability. It's definitely beyond this human's ability. Maybe you can. I won't speak for you. So what did I try? You'll see in a moment. Anyway, my answer still missed the closest answer by 3 degrees. That's not bad on this particular question. Being 3 degrees off from 235 degrees was a little closer than the 9 degrees away from the 247 degree answer. But that still doesn't give me a warm and fuzzy feeling. My answer was in the middle of a 12 degree window and just leaning a little one way. The guess worked, but you can see that if I made the slightest mistake in any part of the plotting, I could easily end up closer to the wrong answer. On a different problem, things become virtually impossible in my opinion. Again, here is the problem if you want to calculate at home. I'm not going to step through how to calculate set and drift. I'm just going to highlight my findings and note the problems I found with the question. Let's start with the time again. In this problem, the start and end fixes were recorded 46 minutes apart. 46 minutes is 0.766 repeating, meaning the 6's after the 7 go on indefinitely, of 1 hour. In the first problem, I showed you the time used was certainly calculated to the tenths of an hour, 1.4 exactly. So in this problem, did the author only use tenths of an hour? Did they round the 0.76 up to 0.8 before using it in a rate time distance formula? Or did they actually use 0.76? I don't know, but the difference is a bit. If the author used 0.76 hours, then the distance of travel on the dead reckoning vector is 5.776 nautical miles. If they used another decimal place and used 0.766, the distance is bumped up to 5.8216 miles. If they round it up to 0.8 hours, then the distance becomes 6.08 miles. That's almost a quarter of a mile distance on the dead reckoning vector, which would change the direction of the set several degrees on its own. Then we have to speculate what the test author did with rounding on the distance. If they went the exact route and calculated 5.8216, did they round that back down to 5.8? Or did they try to plot 5.82 nautical miles? Or did they use a computer and calculate the entire field of decimals? I have no idea. If you do, please drop a note in the comments about how these questions were made. The time and distance assumptions are not the worst part of the problem. We have to conclude what they did for the compass error. First, the problem calls for being on a heading of 310.5 degrees PSC. I'm calling BS on the author of this question right here. No boat that I have ever known is on a half-degree heading. My autopilot can't even deal with half degrees, and I'm sure as hell not hand-steering a half-degree bearing. Do military ships have that precise a navigation technology that they can have a computer steer a half-degree heading? Maybe. I don't know. But in practicality, I have no idea why they would put such a particular heading in a problem. Moreover, in this direction, we have to make a guess at what they are using for compass error. The heading is falling between 0 degrees and plus 1.5 degrees, or 1.5 degrees east. What exactly did the author of the question use for compass error? Did they bump it up a little to make the magnetic heading 311? Did they add the entire 1.5 to make the magnetic heading 312? Did they do something in the middle and make it 311.25 degrees? If they did, are we really expected to plot vectors down to the quarter degree on a chart with a scale of 1 to 80,000? Very literally speaking, the width of your mechanical pencil lead could probably affect this problem by half a degree. If it seems like all these differences are small and I'm getting lost in minutia, I really don't think I am. These differences can affect the results of these calculations of the set by over 10 degrees. Let's look at it. Let me just plot a few of these possible variations to show the difference. Of course, we have to plot the GPS fix noted at the end of the time period, and that is shown here. Next, I'm going to plot, to the best of my computer's ability, which is actually more than my ability, a dead reckoning course of 311 degrees magnetic. Next, I'm going to put the exact calculated distance on the line, as well as the rounded distance on the line. They don't look very far apart, but they're almost 3 degrees difference on the compass rose. Let me try plotting a vector of 312 degrees magnetic at the rounded distance of 5.8 nautical miles. As close as they are, the difference between these three marks is producing variations in set that are more than 11 degrees different. By the way, none of them are the correct set answers according to my practice book. My practice book says the correct answer is right here, right in the middle of the three answers I came up with on my own. I find these test questions to be complete BS. They are not something we are ever going to do. I agree it's important for captains to understand how set and drift affect a boat. I hope I have at least convinced you that I understand how set and drift affect a boat. Even though I know how it works, I don't think I will ever successfully calculate the set and drift that is in one of these answers. And there's a good question I might not even get close enough to make a correct guess. So what are we to do? We still need to pass this test, which needs a score of 90% or better. We can't afford to get questions wrong because they are crappy questions. I feel the solution is to not calculate set and drift at all. Here's what I'm going to do. If I start this problem over, I will start with the time. It's still 0.76 hours. I don't care how fast my boat was going. I'm not going to calculate the distance I was supposed to travel on the dead reckoning line at all. I'm going to jump to the assumption about compass error. When I look at this silly heading of 310.5 degrees PSC, and I see the window of compass error that I could be dealing with, I figure the lowest number the author of the question used was 311 degrees magnetic. That would be just a slight adjustment up from the PSC course. The author certainly could not have added more than 1.5 degrees, which would bring the magnetic heading of the boat up to 312 degrees. I'm also not going to try to deal with fractions of degrees, because I'm just going to screw that up on this scale. I'm never going to get it plotted that accurately. On the chart, I'm going to plot the 311 degree vector and the 312 degree vector to cover the window of assumptions that the author might have made. This forms a wedge shape traveling past the ending fix. This is where I'm stopping when it comes to calculating anything in this problem. From here on out, I'm going to calculate using the answers. If we just look at the ending fix showing where we went and look at the wedge of where we were projecting to be using dead reckoning, we can clearly see the general direction we must have been drifting. If we then look at the answers, we can quickly eliminate answers B and C. 164 degrees and 151 degrees are both southeasterly directions. We can easily see that we did not drift to the southeast from anywhere inside the dead reckoning wedge. We can just cross those two answers out. However, answers A and D are feasible answers. To sort those two out, we need to plot the reciprocal vectors of their sets. It's easy. Go to your compass rose and find 330 degrees true, shown in answer A. Don't forget, set is noted in true degrees, and draw a line entirely through the compass rose on 330 degrees true to find the reciprocal course. Yes, it's accurate that you could just subtract 180 degrees, but I'm a visual guy and I sometimes make dumb mistakes. So this line shows me we need to draw a vector running 150 degrees from our ending GPS fix. Next, we need to adjust the drift for the time of the problem. Answer A says the drift is 1.1 knots. Remember, that's per hour. Our problem only ran 46 minutes, or 0.76 hours. So we multiply the 1.1 by 0.76 to get a drift distance of 0.836 nautical miles. If we return to the chart and plot a vector of 150 degrees from the ending GPS fix and mark the distance of 0.836, or a little more than 0.8 on the tick marks on the latitude side of the chart, we would see that answer A would be correct if our dead reckoning fix was at this position. This position happens to be inside the wedge created for the possible places the boat should have been according to dead reckoning. Winner, winner, chicken dinner. More than likely, this is our correct answer. You can confirm that by repeating the process for answer D, and you will find that fix lands here. When you look at the answers plotted this way, it's very clear which answer the author of the problem had in mind as the correct answer, and you just spent a lot less time than figuring out all of the parts of the problem. Please do not walk into your test center and try this method without exploring it on your own. Get out your practice chart and your practice problems and give this method a try to see if you like the results you get. If I did you a favor today by giving you a new way to look at completing this kind of test question, you can return the favor by liking this video. If you haven't already, subscribe to our channel. It really helps us. Please and thank you so much.